Order of operations. Now we're going to do some order of operation problems involving fractions. Now keep in mind, order of operations in a single word, an acronym, is Pemdas. P stands for parentheses, brackets, braces, absolute value bars, any grouping symbol. Some people call it Gildas. G stands for grouping symbols. E stands for exponents. M and the D go together. It's multiply and divide, whichever comes first from left to right. The A and the S go together. It's add and subtract, whichever comes first from left to right. So Pemdas could be Pedmas, Pimsa, or Pimsa. Keep that in mind. Here we go. Let's do this problem. First thing that I see that I need to do, exponents. So when you see an exponent of 1/2 raised to the second power, the exponent's on the parentheses, so what you can do is just draw two parentheses and place the 1/2 inside both of those. It is true you can do some steps before others and it won't affect the problem. I'm just going to show you every part of this problem just so you'll know exactly what's going on. Here we go. First thing I'm going to do now, I have multiplication. So 1 times 1, when you multiply fractions you go straight across. 1 times 1 is 1, 2 times 2 is 4. Now before I multiply these two, I'm going to reduce. And I see, and once again, when you reduce with multiplication, any numerator can reduce with any denominator. So I notice that 2 and 8 are both divisible by 2, so I'm going to divide 2 into 2. It goes once, and 2 into 8 4 times. 3 and 9 both are divisible by 3. 3 goes into 3 once, 3 goes into 9 3 times. And now when we multiply straight across, we end up with 1 times 3 is 3, 1 times 4 is 4. And as we keep on going, because we have common denominators, we're going to write down that 4 and add the numerators. 1 plus 3 is 4. 4 over 4 is 1. Now consider this example. With the order of operations, when I mark the M and the D together, that means that we multiply and divide whichever comes first from left to right. This problem is missed by many people. A lot of people think that you reduce the multiplication first and then you do division. That's not the case. We're not dividing by both of these fractions, we're only dividing by this single fraction. And so we do the division first according to the order of operations. And all I'm going to do is use keep, change the division to multiplication, and flip only the 4/5 over to 5/4. This 5/4 remains as it is. And now it's all one big multiplication problem, and if I can reduce anything with any numerator with any denominator, I'm going to do so. But as I look, I see nothing that reduces. So now I'm just going to multiply straight across. 7 times 5 is 35. 35 times 5 is 175. Bottom, 11 times 4 is 44. 4 times 4 is 176. And that's how you do that problem. Now let's do one more. This is a common one that seems to appear in these types of sections. Once again, order of operations states that we need to do what's inside parentheses first. So let's look at these two right here. In order to add fractions, got to have the LCD. LCD of 12 and 6 is 12. That's the smallest number that both 12 and 6 divide into. Now some people like to do things really systematically, so that's what I'm going to do. Even though I know what the answer is because the 12 didn't change, so the 1 won't change. But let's do it systematically. People like to get in the habit of doing that. 12 goes into 12 once, and 1 times 1 is 1. 6 goes into 12 twice, and 2 times 4 is 8. Now it is true I could reduce the 2/3 first, and that's fine. It doesn't really make a difference. Either way, we got to change that fraction to a fraction of 12 as the denominator. And so if you did catch that, that's fine. Let's add these two fractions because we have common denominators. Keep it. 1 plus 8 is 9. And now I'm going to go ahead and reduce. 3 goes in both of these. 3 goes in 9 3 times. And 3 goes in 12 4 times. Now let's do the second fraction. Before I do anything, I'm going to put that 5 over 1. That helps me with the LCD. LCD of those numbers, of 3 and 1, is 3. Smallest number that 3 and 1 both divide into. Same process. 3 goes into 3 once. 1 times 2 is 2. 1 goes into 3 3 times, and 3 times 5 is 15. Keep the 3 and let's subtract. 2 minus 15 is negative 13. Going to bring that on down because it doesn't reduce. Now before I do anything, it is true I could multiply and then reduce, but I'm not going to. I see a numerator that will reduce with the denominator. These 3's cancel one another out because 3 goes into 3 once and 3 goes into 3 once. Canceling just means reducing down to 1. Now let's multiply straight across. 1 times negative 13 and 4 times 1. And we are done.